guys, welcome back. All right, so this week you guys have 3 lessons. We are going to skip one of the lessons in the workbook, so just keep that in mind as we're going through here. We're going to start off with 8.6 today. So the first part of 8.6, Mrs. Gonzalez noticed that her new chorus class had a lot more girls than boys in it. There were 32 girls and 17 boys. So what we're going to be looking at are probabilities and percentages, and so we want to round our answers, to the nearest percent. So what percent of the class are girls? Well, in order to figure out what percentage of the class are girls, we also need to know the total number of students in the class. So we need to add our 32 and 17 together. So 32 plus 17 is going to give us 49. So we know it's out of 49 and there's 32. So if we take 32 and divide it by 49, we're going to get 0.65, I do believe. Let's double check it. Yep, so 0.65. Remember, move the decimal place twice. So 65%. So 65% of her class are girls. Now, for number 3, it's telling us that 68% of the girls were sopranos. So, how many girls sing soprano? So now we're looking for the specific number. So we know the percentage of the girls that sing soprano. We want to know how many that actually is. So we're going to take 0.68. So we moved the decimal back and gave us an actual decimal instead of the percentage, times our 32. Now, when we take 0.68 and multiply it to 32, we're going to end up with 21.76. Now, can we have a partial student? Nope. So we're going to round this up to 22 sopranos. Now, for B, what percent of the entire chorus sang soprano? So now we're going to use this 22, and we're going to divide it by our total, 49, and 22 divided by 49 is going to give us 0.4489. So it does keep going on. So in this case, we want to round up. So we're going to have 45% when it comes to rounding it up. Alrighty, so that first section is all about percentages and taking and looking for those percentages. Okay, so on to the next section. So for this, I'm going to show you the online workbook just to make it so you guys can see the graph for this, because we're going to be looking at some graphs. So let me get that pulled up here real quick. Okay, so for number 6, think about the graphs of y equals 2 to the x power and y equals 2 to the x power minus 4. So first and foremost, we're going to take and graph this out. So if we plug in 0, 2 to the power of 0, anything to the power of 0 is always going to be 1. If we take 2 to the first power, we'll be at 2. 2 to the second power is at 4. 2 to the third power is at 8. So on and so forth. Now, going to the other side, so we kind of have our curve here. 2 to the negative first power is going to be a half, because anytime we do a negative exponent, it just flips it. So we take our base number and then we make it into a fraction. And then this is going to get infinitely closer to the x-axis. But we'll never actually cross the x-axis. So here is our curve. I'm going to attempt to draw the line into that curve for us so we can see it a little better. Well, it's a little off, but you guys should have an easier time of drawing that curve in. Now, that is the first equation. So that's this one here. Now, for the second equation, Same thing, but we have the negative 4. So 2 to the power of 0 is 1. 1 minus 4 is negative 3. So we're going to be down at 1, 2, 3. Now, 2 to the first power is 2. 2 minus 4 is going to give us negative 2. 2 to the second power is 4. 4 minus 4 is 0. There we go. 2 to the third power is 8. 8 minus 4 is 4. There we go. All right. And then same thing here. If we take 2 to the negative first power, we have a half. A half minus 4 would give us a negative 3.5. And then we're going to get infinitely closer to the x, or to negative 4 on this case. Oh, and I did a little better. Okay, so these are two graphs. Mine are a little wonky with their lines, but the points are all accurate. So predict what you think is the same and what is different. So what is the same about these two graphs? They have the same shape. So same shape. That's supposed to be an A for shape. But what's different? So they have that same shape. They're each time we're going up exponentially, or we're multiplying by 2 from the previous value to the next. So what's different? The second one is 4 lower. So this second graph here is just 4 units lower all the way through this. So every single one of these points is 4 units lower than the original blue equation. So these graphs are what's known, these functions are what are known as exponential functions. Exponential is your key word for this lesson. Now, you do not have to do part B because you don't have graphing calculators, so you don't have to worry about graphing calculators. That's why we're just graphing these out by hand rather than using the graphing calculators, alrighty? Okay, so that's what you're doing on 6 and 7. So same thing with 7, you do not have to take, obviously, and do part B. You don't have a graphing calculator. If you do, by all means, you could take a look at what these equations look like, but you are not required to, so you don't have to worry about part B. All right, the last section of this one is back to looking at the vertical translations of linear equations. So the graph of f of x and the translation form equation of g of x are given. Graph g of x on the same grid as f of x and write the slope-intercept equation of f of x and g of x. So g of x is f of x minus 5. So here's our f of x. So we're going to start with the y-intercept, and we're just going to go down 1, 2, 3, 4, 5. And then the slope of f of x looks to be down 1, 2, 3 over 1, 2, 3, 4. So we've got a negative 3/4 slope. Our y-intercept on this is at a positive 3. So now finishing off our g of x, we're going to go down 1, 2, 3, and over 1, 2, 3, 4. Go back to the y-intercept and go up 3, 1, 2, 3, and over 4. 1, 2, 3, 4. There's our line. I'm going to attempt to draw it in there, but I make no promises. Not too bad. So there is our g of x function. So for g of x, the slope is going to remain the same. Remember, these will always have the exact same slope. That's never going to change because we're doing the translation. We're just moving it up or down, and you use the y-intercept to help you. So then, because we subtracted 5 from 3, we were down at negative 2. So our equation for g of x is negative 3/4 x minus 2. So you guys will do the same thing over here on 9 and 10. So make sure you graph it and then give both of the equations needed. All right, so a reminder, your keyword for this lesson is exponential. If you have any questions, feel free to send me an email. I'll try to get back to you as quickly as possible. Have an excellent day and happy mathing.